Hey there, welcome back to Coding at Home. Hey, I'm Matt from the Code Hub. Welcome back to Coding at Home. Today we are probably finishing up our work on the Sonic Workshop, and we are going to be exploring the stuff that we learned over the past little while, and then we're also going to go look back at Swan's Quest. If you remember from WWDC a week ago, over a week ago now, we looked at a lot of interesting playgrounds from the Swift Playgrounds team at Apple, and they walked us through how to complete Swan's Quest. Well, we're going to go back to that now that we've done Sonic Workshop and see where some of those lessons we've just learned can be applied to the work that we did in Swan's Quest. So let's kick it over the iPad and get started. All right, so here we go. We are ready to open up Swift Playgrounds again today. Now, hopefully you have your copy of Sonic Workshop already downloaded. If you're just joining us for the first time, you might want to catch up on some of the sessions from last week. You grab the Sonic Workshop from here in the challenges. What we're going to be working on a little bit later in the week, I think, is going to be Sensor Arcade. That'll be our next one. So if you want to get ready, you can go and download that now. But we're working in Sonic Workshop, which, as it says there, is a bit more of an intermediate playground. Just like Lights, Camera, Code. It's not rocket science, but it's just that little bit more challenging. And it helps to have gone through all of our material with Everyone Can Code Puzzles and Learn to Code 1 and 2. All right, so I'm working in Sonic Workshop copy 2, so I'm going to open that one up. And you can see we've gone, I know the weekend can be tough, you might have forgotten where we are. We worked on cave sounds, where we were introduced to closures for the first time. If you recall, here we go. And a closure is just an unnamed function. Some functions we're going to call, some methods we're going to call take a closure. And more often than not, it happens when we have to go do something that takes a bit more time. So we have to tell the iPad to go off and think about it. You go off and process that on another, what's called a thread. You work on that on another thread, and then come back to us when you're done, and then you're going to run this code. That's the major case where closures are used. So we did cave sounds, where we introduced to closures. We added things like touch handlers for our graphics so that when we tapped on certain crystals, they played music for us. Then we reused this function here in our crystals file, this create crystals file, where we create our own code to be run when you touch a graphic. We got to creating our own function, which, because this is all shared, this crystals file is shared, we see the same code. It's not changing every time I tap to a new page. This is shared for all pages in a playground. So we created this create color changing graphic. And we have an on touch handler as well. So when we move our finger on it, we respond to this set on touch move handler. And it'll change the hue of the graphic. So let's run our code and just see what that looks like again. So this mushroom here is the one that I have set using that. The looping graphic that I created is here. We'll tap on main to see that. So here's our green mushroom, and we use the create color changing graphic function that we wrote in crystals. And then the looping graphic is this one here that we created with our create looping graphic function. So to start, this is our color changing graphic, and we have our set on touch moved handler. So when I tap on the mushroom, say down at the bottom, and I move my finger up, we can see the color change. If I go very slowly, we can see it change slowly, or we can have it change fast. Now it changes a lot as my finger moves up and down that mushroom, that graphic. And we were looking on Friday, we did a cool little dig to try to find out where that on touch moved handler gets called, to see how it's getting called so often. We'll go and look for that in just a second. The other thing we have created here was our graphic with the create looping graphic. So if I touch on my graphic, it's going to toggle this loop that we created with a certain sound that was passed in. So if I tap on my crystal over here, we can hear that sound loop over and over again. And if I tap it again, it stops. So toggle the loop off. So that's where we're at. And we got through all of this code. We started our function. We talked about what a function definition was, and it's basically just this. You know, the name of the function, the parameters, so in this case an image and a sound. And then this little arrow followed by the graphic means that I'm going to give you back a graphic when you call this function. So the touch moved handler we're going to go into in a second. We added all of this stuff. We looked at how we could play music or play an instrument. And there was a small bug, remember, with our graphic where we weren't hearing the instrument play. So we can go dig into that a little bit more today too. We did this part where we looped our sounds. Here's the code example if you want to drag any of that stuff out. And now we're at the stage where we can add visual flair. So I'm gonna, for our looping graphic, let's have our graphic glow. We can have it shake, we can have it scale. I'm just gonna make this graphic glow when we touch on it. So because I wanted to have it happen when it gets touched, I want to do it inside my onTouch handler. So I'll do graphic dot glow. Now you might be wondering why, here let's expand this so we can see our code a bit better. Why, when I say graphic set onTouch handler down here and I have it glow, why both of them? Graphics that are created in the create looping graphic and graphics that are created in the create color changing graphic aren't getting the same behaviors because they're named the same thing, right? They're both called graphic. But if you look here, we actually declare a variable here, a constant for our graphic inside of our braces. So because we declare it inside our braces, this name, this graphic name, only has any meaning inside here. So that's the only one it cares about. So this graphic here, 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 and here all refer to this one inside of our function. It just so happens that we called them the same thing, but we don't have to go calling this one graphic 2 so it doesn't clash with this one. All right, so there's our, let's try running this and see how our glow works on our crystal. There's our onTouch moved handler. There's our loop. There's the glow. Okay, cool. Looking pretty good. Now, one last thing I'd like to check out here is maybe we have an issue if we try responding to the onTouch moved handler and we have an onTouch handler that plays an instrument. So just for kicks, I'm going to try commenting out this whole thing here. Now, this is how we usually comment out things. We put 2 slashes in front of our code. Now, if we want to comment out something that's a much bigger chunk of code, there's another way to comment out our code. So I'm going to tap here behind where we create our image. I'm going to hit return. So the way you can comment out many lines of code is by going down and grabbing a slash from above the C. And then the next thing you're going to grab is the asterisk over the V. And you can see that it just colored a whole bunch of stuff green. It's not going to uncolor it green until we put a trailing one. So we need to just do the opposite. We need to get an asterisk and then a slash. And you can see the code after that turns white again. So what we've done is we've said, hey, Swift, you're going to ignore all of this stuff in here. So let's try running it and see if that doesn't fix our play instrument bug. All right, so now we're going to tap on the mushroom and see if it plays our instrument. Oh. Yep, I hear it now. That's cool. All right, let's try. What did we have? 80, I think was the note that they recommended we try. Let's try running that. Okay, that's you can hear it every time I tap on my mushroom now. All right, cool. So we fixed our play instrument bug. Let's change it to something a little more distinctive so we can really hear it. And then we'll try to uncomment that other code, and we'll see if that's not the cause of our bug. All right, there's our electric guitar. All right, so now that we've isolated that, and we said, all right, cool, if we turn off our onTouches moved handler, we can hear the code that we write in our onTouch handler. Let's remove these comments. Now I'll hit run my code again. You see I just deleted the start multi-line comment note and then the end one. We'll hit run my code. Okay, now we'll touch on the mushroom. Oh, there we go. Now we have it. Maybe it was a Friday bug. It's like we're good to go. Maybe started over the weekend, and that's what I'll be. Anyway, it was good to go into a bit of debugging. Sometimes you might think, this might be an issue because we have an on-move handler and an on-touch handler, maybe one over the other. So we needed to look into that a bit. All right, so we started on the last page here. So now we have to check. We ran our code, our file is executed, and it sounds and looks the way we want. Now we're going to try call some functions. So this is a little bit more straightforward. You got used to this. Some parameters we can set, the way it behaves. But before we do that, let's look at the source of that on-touch mover. So I'm going to go up to the three dots here. And on that down here. View auxiliary source files. Now we went digging around in here the other day on Friday. Let's look at modules, because that's where a lot of code for the book is kept.
It's like laggy. It's
Laggy, okay, alright.
There's a little bit of, I think you're dropping frame.
So do I need to slow down?
It's just stop pausing. It's not loading. So
Downstairs it's not.
it's not loading. It's just slowly. It's working.
Okay, all right. Thank you, guest star for the day. Okay, so hopefully you're seeing this. Hopefully it's not too laggy. Actually, tell you what, we'll plug in here that's less laggy because we have an air server, which is a great tool, but this might be a little more reliable. So let's try this out. All right, so just so you can actually see what we're doing, we'll switch to nope, not that one. We'll just quickly switch, and when I say quickly, I mean not quickly at all. Switch over to our other connection and see if that works. Because I don't want you to miss this out. You know what? It's good because I'm mirroring. Hold on. Let's stop mirroring for 1 second. Here we go. Bear with us. I swear it's worth it. All right, here we go. Maybe it's not going to work. Maybe we'll go back to... All right, tell you what, we're just going to soldier on, and if it works, it works. If you don't see it, tough. All right, here we go. So if you can see it, great. If you can't, well, we'll try to record this after the fact, and you'll be able to take a look. So I went digging around over the weekend into where that OnTouch Moved handler was being called. It's kind of nice. You can go back to your Mac and open these playgrounds up in Xcode, and you can have a search run. You can use all of its tools and its search capabilities to go find source code. So I just did a quick search for set OnTouch Moved handler and found out where it was used. So I looked in, if you look in SPC scene.playground module. So this is where we started. Let's start from scratch here. So I went to the 3 dots. I picked advanced. And then I picked view auxiliary source files. And then inside there, I went to the contents. And inside there, I went to modules. And you see this SPC scene.playground module. I'm going to open that one up and look in the sources, because that's what we really care about here. So there's a whole bunch of stuff in here that help drive our playground. We looked in graphic, if you remember, because that's what we're creating. And we can see that there's if we scroll down, here's our property. It's a public var OnTouch Moved handler. And even though we went digging around in here, we don't see where it's called yet. So I had to go back. If you go back to the back arrow and you look in the scene down here, this is where you're going to find when the OnTouch Moved handler gets sent. So we can scroll way down. We can see where we're adding and removing graphics from the scene. This is the thing that actually draws all of our stuff on the screen. There's a background image. Here, again, is our OnTouch Moved handler. There's even an OnCollision handler, which is kind of interesting. We can see where the place method comes from, right? So this is where we have to use this thing called a scene proxy, because we're in a playground, and we need to do a little bit of communication across a little bridge. There's circle points, square points, and you can see this is a fairly large file. You can see from this scroll bar here that we've got quite a bit of file to get through here. But here we go. This is what we're looking at here. This scene touch event. This handles all logic for touches that are passed through from the live view scene. So that live view scene is that thing that we normally see over on the right-hand side of the screen. And we can see that there's a lot of logic here. Now we get a touch type sent through to us. They store it in a variable. And then they have this touch moved handler, touch handler. And this is where they actually call our closure. This is what it looks like to call a closure. You don't necessarily have to have this question mark. That's something else again. But this is where it looks like it's calling any other kind of function except for the question mark, where it's passing in the touch that it receives in this scene touch event. So this is getting called many, many times a second. And that's why we're able to see the hue of our mushroom change so frequently when we move our finger up and down on the mushroom. Now, this isn't for everybody digging around in this kind of code here. It can be kind of fun and kind of enlightening sometimes when you go digging in and looking at how somebody else, especially how really good engineers have organized their code. There's a whole bunch of other stuff in here and a whole bunch of other concepts in here that you might not be familiar at all. But as you see them here and you kind of poke around with them a little bit, you might get a little insight into how other people have organized their code, and then decide to go search up how they organized it or why they organized it a certain way and what tools they used. Like we see this keyword we haven't seen ever before, this extension keyword. It's kind of an interesting feature of Swift. All right, so that's where it is. So if you want to go looking for it, again, it's in SPC scene.playground module, which you'll find inside our playground book inside the modules directory. So if you want to find out, if you want to try to reverse engineer how they're handling touches and how they're calling that closure that we provided. All right, so I'm going to hit done. We checked our work. Let's go on to the next page. I'm going to just hit next here. All right, so now we've written a few of our own, like it says here. Now we're going to learn to call built-in functions from other shared files. So we can see them here in the tab bar. So we have our crystals file. This is all the code we wrote. So our color changing graphic, our looping graphic. And we have a few new ones. We have a cave glitter file that's got a public function here called add cave glitter. Let's see, and that's it in that file. Let's tap on this one. This is called graphic cluster. We can add a graphic cluster with an array of sounds. That's what those brackets mean, you remember. And if we read through this code, we can see that for a graphic cluster, we pass in one image, an array of sounds, and then we give it a point where we want to add that cluster. So the first thing it does is it creates a variable called graphics. And this funky syntax here means that, well, this we know. These two braces here mean that it's an array, and it's going to hold objects of type graphic. And then these two parentheses, this empty parentheses, just means that we're creating an empty array that's going to hold graphics. And then they've got it nicely commented. So for every sound specified in the sounds array, when calling the function, create and place a graphic from the provided image. So let's see. So it says for count in 0. This is just looping through our sounds array. Now we could have done this another way, right? We've seen the for each loop where we do for sound in sounds. We could have done. This is another way of doing that. So we create a graphic with that image. We set the on touch moved handler. Oh, and we can actually access this property on touch called double touch. And that tells the cluster to play all the sounds and make all the graphics glow at once. So we do the same thing. We actually loop through all the sounds and we play all of them. And we loop through all the graphics and we make them all glow. Then we can do this test here to see if first touch in graphic, that must be a Boolean, right? If we're doing else if touch, first touch in graphic, we'll just play it the once. We have a variable called offset, which I'm guessing they're going to use to keep moving the graphics as they create a cluster. And you can see they do a little bit of they do a rainbow color, so they get a color just like we did with our untouched move, we used the touch position to figure out what hue we were going to use. They're actually using the count that we're on. So if we have 6 sounds, it would be anywhere from 0 to 6 or 0 to 5. Or if we started at 1. Yeah, we'd start at 0 here. So that's our count that we're using. And we set, they've got sort of hard-coded saturation, brightness, and alpha. They get a random double from 0.25 to 0.5 to change the scale. And then they go place them all on the scene at random places. And they have accessibility hints, which is kind of nice. And at the very end, they append that graphic to the graphics array. So we have the cave glitter file. So let's try doing that. Let's try calling cave glitter here and run our code. So we've got to call cave glitter from the main file, right? Because if we added in any of the other ones, it doesn't get run automatically by Swift at the start. So let's add cave glitter. There it is in the autocomplete down here. So we have a uint. Basically, uint just means it has to be a positive number. We can't give it a negative number. Let's make it kind of large. Let's make it 100. And in terms of color, maybe we'll grab this guy and let's do a green color. We can specify a gradient color. So we'll grab another color swatch from down at the bottom here. And let's pick this color, and then we'll put it right in the center to start. We'll pick an X and a Y. To put it right in the center, we do X is 0, Y is 0. And we'll run our code. Okay, kind of interesting that that's our glitter. Not bad. You can see it's got my 2 colors in there, my green and my kind of pink. Alright, so that's our cave glitter. You can see they use 50 and they put it up in the corner. Let's try the graphic cluster and let's just keep adding here. So we'll scroll over and we'll tap on add graphic cluster. So now we just pick one image. So we're going to use an image literal to make this easy. And let's see, we're going to add this one. Use that image. And we'll give an array of sounds. So luckily, we've got a placeholder here with values in it. We can pick that to create our array. So we can add sounds by, let's use boops. And then to add more items, I'm going to tap on the 2 dots there at the end and drag over. Let's add maybe 5, sounds pretty good. And we'll do dot. We'll do just regular boops. For that one, we'll do dot. Maybe broken glass, we'll stick with the bees. Dot. Maybe we'll do, let's do slime. And then our last one will be dot Space Carnival. So let's, we can add this at a certain point. Let's maybe add this one up in the corner. So we'll pick point. Use the parentheses, X and Y. And we're going to specify, say 200 on the x-axis and 200 on the y-axis. And let's run our code. Okay, there's our graphic cluster. Kind of cool. You can see the hue code that we were exploring a little bit earlier. You can see as I tap around the cluster, different ones glow. And now you remember there was that double tap, if touch dot double tap. You can hear all of the sounds play. Okay, not bad. Let's see what the next thing is to add. All right, we're going to add graphic loops. Let's do that. So we're going to add graphic loops. We'll see what the signature, what the function definition looks like. So we need an image, so we'll pick an image. Let's see, we'll pick something from further down the list. Maybe this one. We'll use that. We'll add some sounds. Try to make it different than the last one. We'll pick the values down here in the autocomplete bar. We'll do dot. Let's do drill. And then I'm going to drag out and add a couple more. We'll add just 4 for this one. So dot email. Tap on the next item, dot. Galactic chime. And then the last one we'll do dot. Let's do Tesla coil at point, and we'll have this one be lower. We'll have it down in this lower corner over here. So we'll pick a point, create our initializer. So we'll do minus because we're going to put it on this side of the x-axis. So we'll do minus 200, and we'll do minus 200 for the y position as well. Okay. Here are our graphic loops. Let's see what that does when we tap on them. All right. Let's have a quick check at graphic loops and see what we're doing. So again, like we did with graphic cluster, we loop through all the number of sounds that we have that we pass in this array. We create a graphic for every single sound. So we create a graphic and a loop which plays the sound and causes that graphic to glow on each cycle. Okay. So we have a loop, and then loop has another property on it where we can pass in a closure. So this is just like we were doing with our set on touch move handler here, where we have our touch parameter. And if we get our first touch, we just toggle the loop on and off. But our loop has a loop fire handler. So on each cycle, this code is going to get called. Now we know that because that comment has told us. The only other way we would know is if we went and read the code. But this is kind of handy to know that there's a closure that we can set as a property on our loop, and that this code that we pass in will get run whenever the loop is recycling. And so we just have it glow. We set the radius. We have it glow for the length of the loop. So there's a property on loop called length. And we just have it do it once. Now we have a delta X, a scale. These are going to be how we place our graphics around the scene. So we use that delta X to change our value on the X-axis. And then we do a little bit of math to figure out where we're going to place it on the Y-axis based on the scale of our graphic. Let's try running that and checking it out again and see if we can identify that behavior that we see in the function there. So this is our graphic loop down here. All right, so that's our drill one. And you can hear it looping through every time, and the glow kind of matches the loop. Okay, there's our galactic chime. Sounds a little bit wild. And then we can go and look at our tone generator. This looks very similar to what we saw in Swan's Quest. There's our tone output that we did see in Swan's Quest. And we can add tones. We pass in an image at a specific point. And then it will adjust the range and the pitch. The range looks like a constant, so it's not going to change. That's going to be just 10. The pitch is going to change. And it happens when it's not the last touch in the graphic. So let's try this one out. Let's go back to our main file. And we're going to add our last thing here, our tone generator. So we're going to add tones. We're going to pick an image. We'll use this oyster. And for our point, we'll put it up in this corner over here. So we'll do an initializer. On the x-axis, is that positive or negative? That's going to be negative. On the y-axis, it's going to be positive. And let's try running it. Now I'm going to move my finger over. Alright, so we got kind of a screamy clamshell out of the whole deal. Not bad. That's our tone generator. So just a quick question before we go today. So this is our if this was our function definition, this create water sparkles, how would you call this function in the main file? So would you call it like this? Would you say let diamond equal create water sparkles? Well, that's potentially valid because we do return a graphic, but we're not passing in any parameters, so that probably wouldn't be it. If we look at this one, well, we're going to store it in a variable called diamond, and we call create water sparkles image. Okay, that's the right label. Anyway, with an image, and then a sound.steeldrum. I think that might be it. But let's just check. This last one is we just call it, but we don't store what's returned anywhere. So I would guess that it's this one here. So if we hit confirm, we'll see that that's right. That's the way we would call a function that looks like this. So that's really what you should have gotten out of Sonic Workshop is we can now read our functions a little bit better and understand how we might use them. So we even saw some advanced stuff where we assigned a closure to a property, but we assigned closures as parameters for a function, which is huge. That's a really big step. So I think we've done pretty well. We've learned a lot out of Sonic Workshop. Tomorrow we'll have a quick look at Swan's Quest to maybe get a little refresher. As it says here, we're ready to move on after we finished our Sonic Workshop. We might play around with Sensor Arcade the next time we come back on Wednesday. Tomorrow's session will likely be at 3 o'clock Irish time. I hope you enjoyed that. We'll have a little look at Swan's Quest tomorrow and try to apply some of the lessons that we learned in Sonic Workshop. Until then, happy coding.